Hey everyone, and welcome back. Before you watch this walkthrough, make sure that you pause the video and try the problem yourself. Even a partial attempt will make the explanation that much more useful. These videos are meant to support your problem-solving process, not replace it. Across a lot of my practice problems, I highlight different aspects of how to approach, break down, and reason through problems. So you're going to get the best benefit by watching multiple walkthroughs rather than treating any single one of my videos as a template that you can copy. With that, let's get started. Today's practice problem is going to be summing an array using a recursive method. The question is as follows. Write a recursive method that returns the sum of all values in an int array. If the array is null or empty, you may return 0. So we can see here that we have an array with 4 values in it, 3, 5, 2, and 7. When we add up all those numbers, we of course get 17. Now, before we touch any code, let's talk about how recursion actually works in real programs. Recursion is just a method calling itself, but that alone isn't really that useful unless each call makes the problem space smaller and smaller until eventually it stops. Every recursive method has two parts: a base case that stops the recursion and a recursive case that moves the problem closer towards that base case. So now let's apply that thinking here. The full problem is summing an entire array, like this one right here, all 4 elements. And a smaller version of this problem is summing everything starting from this position to the end. And an even smaller version of that problem would be summing just the 2 and the 7. An even smaller version is summing up just 7. And really, the smallest version is when there are no elements left to add. And if there are no elements left to add, such as an empty array, as we are told, we could return 0. So that needs to be our base case. In order to keep track of where we are in our array, we need to use an index parameter so that we can keep ourselves moving along. Let's write all this out using comments first. I'll go over here and start with my main method, where I'll go ahead and just make an integer array with those values that we just saw over here. So 3, 5, 2, and 7. 3, 5, 2, and 7. I'll go ahead and make a summation method, sum recursive, that can take in my array for just a minute. That might change, but I just want to get this all set up here. Sum recursive. We can take in our int array. And so far, we'll just have it say return 0 with a printing of array sum value. There we go. All right. Let's get the actual logic in here now in those comments, in that sumrec method. So like we said, if the index is past the end of the array, we can return 0. Otherwise, return the current element plus the sum of the rest. Now it's really important we read these comments carefully. If there's nothing left to process, the sum would be 0. Otherwise, I can take the current value and add the result of solving a smaller problem, being the rest of the array. So let's convert this into code. Let's start with our base case. Now this talks about an index. The index is something that actually is going to need to come into this function. So that way we can keep track of it outside of each of the individual calls. When we start our array off, the very first element would be 0 in the 0th position. So now we can go ahead and do the check of if the index is greater than or equal to our array length, we can return 0. So remember, we said if the index is past the end of the array, meaning index being array.length or greater, now we can return 0. This checks if we've moved beyond the last valid index. This is our base case. Now let's take a look at our recursive case. It could be an else. It actually doesn't need to be, thanks to this having a return right in there. And I'm a little apprehensive to say it, but this is one of the rare cases where we are now allowed to use multiple returns. If you find yourself using more than 2 returns, you probably have too many and should try to rewrite it with variables. But in this scenario with recursion, we often do allow two return calls to be listed there. So now let's get our recursive case in. We said we're going to return the current element, which would be array at the current index, plus the sum of the rest. Well, how do we get that sum? We need to go ahead and call sum recursive again. And this time we're doing it on the smaller, there we go, the smaller problem space. So our index moves along. And this is our complete method. Let's just walk through it with our sort of array, our sample array up here, 3, 5, 2, 7, right? So we start by calling sum with index 0, meaning it'll get called on the value 3. So this is going to return 3 plus the sum of the rest of our array, right? This now calls again. When it calls again, it calls it on index being 1. So at the 5 position. This is now going to, let's even write this in comments. First we had 3 plus sum of 1 to n. Then we saw, okay, index goes up. We're going to need to do sum of 5 plus the sum of 2 to n. This call generates the next layer, our index increasing to 2 plus the sum of position 3 to n. We then have 7 plus sum of 4 to n. This right here hits our base case because our index is 4 and our array length is 4. So they are now equal. This is going to return 0. So that's like putting a 0 right here. Now what we see happen is we get that 7 plus 0, which will equal 7. And this number right here is going to be the return to this call that occurred right here. 2 plus 7 is going to be 9. This 9 is going to be the returned value to this call right here. So 5 plus 9 is 14. And then this 14 is the returned value to this call right here, giving us 17. This 17 is the return to our original call all the way up here on line 4. And that's how we get 17 coming out of this. We found our final answer. Let's run the code just to confirm it, of course. All right. And there we go. We've got our final answer. The key takeaway here is that each recursive call does a little bit of work and then passes the rest of the work forward until our base case can sort of tie up our loose ends and finish everything off. Once the base case hits, the stack can start to resolve itself, working its way backwards until we end up with our final answer. That's it, and now we've solved this problem. Now remember, you won't find my solution posted alongside this video. If you watch the walkthrough without first attempting the problem, stop here, close my solution, and try to write it yourself now. Post-walkthrough practice still counts. If you have questions about this problem or suggestions for future practice videos, please be sure to leave them in the comment section below. Thanks everyone, and I'll see you next time. Bye.